Yes. We'll start within, no, time is 9:21. We'll start exactly 9:25. 9:25 we'll start it. Yes. Okay. Right. We can start. So I think we discussed linear motion, vertical motion, projectile motion, motion graphs also, theory fully finished. And today plan is to start. Plan is to start. Plan is to start what? Newton laws. I think already I sent the tudes. I think already I sent the tudes for the online people. Already I sent the tudes. Okay. Now this lesson is really important lesson. There is no doubt. This lesson is really important lesson. Hereafter, without knowing forces, we will not be able to understand all the other chapters in mechanics, right? Still, we have to learn plenty of theories in Unit 2 mechanics. Without knowing forces, we are not able to understand any idea, right? So, where is the first part? Forces part one. Okay, right. Okay, we'll discuss and put your main topic. Put your main topic. New chapter. New chapter. Put your main topic. Uh, put your main topic. Mm, yes. So now today plan is to discuss Newton laws only. Okay. Now already you learned there are three laws in Newton. Newton's first law, Newton's second law, and Newton's third law. And you learn these three laws in all levels, there is no doubt. But before discussing Newton laws, first we should have a good understanding about linear momentum. Linear momentum, right? Have you heard anything about linear momentum before? Do you know there is a physical quantity named linear momentum? Do you have any idea about what is linear momentum? So I think most of you have no idea about linear momentum. So therefore, therefore, yes, we will discuss motion graph questions after discussing 2.5 hours late. After discussing these Newton laws, we'll discuss some remaining motion graph questions as well. Okay. Now put your main topic, linear momentum. Main topic, linear momentum. Linear momentum. Right? Linear momentum. Okay. Linear momentum. Write down linear momentum, the symbol. Linear momentum, the symbol is capital P. Inside the bracket, capital P. Linear momentum, inside the bracket, the symbol is capital P. Now we know that when an object moves with a velocity, do you know what is velocity? Velocity means a vector. And what is the unit to measure velocity? Meters per second. Dimensions of velocity is LT minus 1. And you know what is mass? Mass of an object, you have an idea. Now I'm considering, now there's an object. At a certain instant, that object moves with a velocity of capital V. There's an object. Mass of this object is simple m. At this instant, this object moves with a velocity of capital V. Capital V. Capital V. Now, linear momentum means, remember, it's a physical quantity. Linear momentum defined as the multiplication of mass of the object into that instant's object's velocity. Linear momentum is, always remember, the multiplication of mass and at that instant that object's velocity. That is what we call as linear momentum. Red color pen, write down. Red color pen, write down. Write down. The write down the product of the product of mass and the product of mass and velocity. The product of mass and velocity of an object under motion. Of an object under motion. Of an object under motion. A blue color pen write down is defined as linear momentum. Is defined as linear momentum. Okay. Linear momentum means mass into velocity. Mass into velocity. That means I can write down an equation for linear momentum. Linear momentum means we know linear momentum means mass of the object into velocity. Mass of the object into velocity. If I write in symbols, symbol for linear momentum is capital P. Capital P means mass simple limb into velocity capital V. This is the equation. This is the equation. Keep on writing this. Keep on writing. You also keep on writing with me. Keep on writing. Now let's consider. Now we'll understand further about this physical quantity linear momentum. Shall we find the units of linear momentum? What is the units to measure mass? Kilograms. Kilograms. Unit to measure velocity, meters per second. Meters per second. Then what should be the units of linear momentum? Units of linear momentum must be kg ms minus 1. Units of linear momentum will be kg ms minus 1. Kg ms minus 1. Right? Write down the units of linear momentum. The units of linear momentum is kg ms minus 1. The units of linear momentum is kg ms minus 1. Kg ms minus 1. And also find the dimensions of linear momentum. Find the dimensions of linear momentum. How can I find the dimensions of linear momentum? I can write down dimensions of linear momentum. When you write a linear momentum inside a square bracket, it says about dimensions of linear momentum. That means that is equal to dimensions of mass into dimensions of velocity v. Then we know dimensions of linear momentum means dimensions of mass. Mass means capital M. Capital M. Velocity means LT minus 1. LT minus 1 dimensions of velocity. Then we understand dimensions of linear momentum will be MLT minus 1. MLT minus 1. Next point, write down dimensions of linear momentum MLT minus 1. But also somewhere else write down these things also. The next point, dimensions of linear momentum is MLT minus 1. MLT minus 1. Red color pen, write down next point. Red color pen, write down linear momentum is a vector. Linear momentum is a vector. Linear momentum is a vector. The direction of linear momentum, the direction of linear momentum, the direction of linear momentum always in the direction of velocity. Always in the direction of velocity, because we know velocity is a vector. Whatever the direction of velocity, that is the direction of linear momentum. I told you the direction of linear momentum is always in the direction of velocity. For an example, if I ask you, now this simple M mass moves with capital V velocity. What is the direction of velocity? Horizontally right side direction. What is the direction of linear momentum? Direction of linear momentum means capital P to the right side direction. Direction of linear momentum also capital P to the right side direction. That is the idea. Sample question, write down. Sample question 1, write down. An object of mass 5 kilograms. An object of mass 5 kilograms. An object of mass 5 kilograms moves with the velocity. Moves with the velocity. Moves with the velocity of 10 ms minus 1. Of 10 ms minus 1. Of 10 ms minus 1. Of 10 ms minus 1 to the right side direction. To the right side direction. To the right side direction. Full stop. Find the linear momentum of the object. Find the linear momentum of the object. Find the linear momentum of the object. I posted these tudes, okay? For all these online people, I posted the tudes. Find the linear momentum of the object. I will give 5 seconds, quickly finish the question. 5 seconds, base substitution. Mass of the object is how much? Sample question. Mass of the object is 5 kilograms. Velocity 10 ms minus 1, right side direction. We want to find what? We want to find the linear momentum. There's an object. Simple M, mass is 5 kilograms. Velocity of this object, I say capital V, velocity is 10 ms minus 1, right side direction. If I want to find the linear momentum P, what is the equation? Linear momentum equals mass into velocity. P equals mv. P equals mv. P equals mv. Mass 5 kilograms. Mass 5 kilograms. Velocity is 10. Then we can obtain our linear momentum as 50 ms minus 1. 50. What is the units of linear momentum? kg ms minus 1. We must mention kg ms minus 1. But remember, linear momentum is a vector. Generally, you should represent the direction as well. What is the direction of linear momentum of this object? Always in the direction of velocity. Velocity is in the right side direction. Direction of linear momentum will be in the right side direction. Okay. I think you guys understand this idea. Right? Okay. Sample question number 2. Okay, before doing sample question number 2, look here. Now you know that. Now the idea. Now see. Now based on this theory, what you should think, what you should argue. Now we define linear momentum means mass into velocity. In the universe, can you find any object having zero mass? Even you consider very small tiny particle has some kind of very small mass. In the universe, whatever the objects that you see all have kind of mass. Then is it possible to have an object with zero mass? No. In a question, if they mention this object's linear momentum is 0, then what is the conclusion you take from that idea? That object is at rest. Am I correct? Because we know linear momentum means mass into velocity. We know for any object, mass cannot be 0. But it's possible to have 0 velocity for that object. Suppose if this object is at rest, what is the velocity of this object? 0. Then, if this object is at rest, velocity 0 means m into 0. 5 kilogram into 0 means linear momentum will be 0. Right? So therefore, remember, linear momentum can become 0 if and only if velocity of the object is 0. Other than that, if that object is under motion, no matter object is moving under constant velocity or object moves under acceleration or deceleration or whatever the motion, object has a velocity. Therefore, definitely object has a linear momentum. Red color pen write down, red color pen write down. The linear momentum of an object becomes zero. The linear momentum of an object becomes zero. The linear momentum of an object becomes zero if and only if and only if and only if and only if velocity of the object is zero. Velocity of the object is zero. Velocity of the object is zero. Okay. Now next idea. Now actually I want to teach you Newton laws, but without having this idea, you are not able to understand Newton's second law, right? Now, next idea is a change in linear momentum. Change in linear momentum. Change in speed. That means what? Change in speed means final speed minus initial speed. Change in velocity. Change in time. Change in volume. Likewise, change in linear momentum. Next idea, change in linear momentum. Change in linear momentum. So we'll do until now, it's 10 o'clock, 11, 12, until 12 o'clock we'll do this, and after 12 o'clock we'll again go back to motion graph, some again questions. Change in linear momentum. Notation is delta P. Usually we use delta symbol to represent a change, right? Notation delta P. Now, just think that an object undergoes acceleration. I will ask you a question. Now, there's an object. That object undergoes acceleration. Right? Want to answer online people also, I want you to raise your hands or raise down. Okay, that's the way. You want to only click one button. Right? My question is, if that object undergoes acceleration, raise your hands. How many of you say linear momentum of the object remains constant answer? If an object undergoes acceleration, raise your hands. Linear momentum of the object remains constant answer. Constant. Linear momentum should be increased answer. Linear momentum of that object should be increased. Right, okay? Because if that object is under acceleration, we know that what can you say about the velocity of the object? Increases. Okay? If an object is undergoing acceleration, we know that according to this equation, velocity is increasing. When velocities keep on increasing, but mass is constant, same object, mass constant, velocity is increasing means accordingly linear momentum also must be increased. Okay. Now I am considering a situation, object undergoes acceleration. Now, mass of the object is simple limb. When the time is, I say, t equals t0, initially, if when the time is t equals t0, velocity of this object is capital U. Okay. After now this object, just think this object is undergoing acceleration. If not just think, this object is undergoing deceleration. I want to tell you, in the motion, velocity of the object is changing. That's what I want to point you. After some time later, now velocity of this object is capital V. But remember, V is not equal to U. Okay, sometimes V can be larger than U if it is undergoing acceleration. V is less than U if it is undergoing deceleration. When the time is simple t. I say, when velocity is U, linear momentum, I mark it as capital P1. Okay? When
velocity is u. I say linear momentum of this object is capital P1. But always remember linear momentum is a vector. When the velocity is capital V, linear momentum of this object, I mark it as capital P2. Capital P2. Okay. Right. Now, what is P1? Initial linear momentum of the object. What is P2? Final linear momentum of the object. Now I am writing something like this. Now, initial linear momentum. So you can also write with me. You can also write with me, draw this diagram, but keep on listening. When you are while listening, write down. Initial linear momentum. Initial linear momentum. That means capital P1. Can you please tell me capital P1 in terms of M and U? Initial linear momentum P1 means mass into velocity M into U. I can write down P1 as what? M into U. That means MU equation 1. Okay, very easy. Final linear momentum, if not terminal linear momentum, final linear momentum, that means capital P2. Capital P2 means what is the mass simple M? Velocity, final velocity is capital V, M into V. Okay. Now in a question, if they are asking what is change, if they are asking us to find the change in linear momentum, what you can do, always remember, change in linear momentum means final linear momentum minus initial linear momentum. Okay, write down with me. Okay, change in linear momentum. This means final linear momentum minus initial linear momentum. Final linear momentum minus initial linear momentum. Now, final linear momentum means now delta P, that means delta P. Delta P must be equal to final linear momentum means P2. P2 is final linear momentum P2 minus initial linear momentum means P1. P2 minus P1. P2 minus P1. If not, we can write down from equation 1 and 2, we can write down like this. From equation 1 and 2, I can write down. From equation 1 and 2, I can write down. Delta P means P2. Final linear momentum means MV. M into V, capital V minus. From equation 1, P1 means what? P1 means M into U. M into U, MU. MU. Okay? Right. Keep on writing. Keep on writing. Repeat it again. What want to repeat, sir? Video is not bit clear. Are we going to discuss motion questions today? Yes. Still it's blurred. Give me 1 minute. Uh, okay, now I think it will be all right. I think it will be all right within 1 minute. Think so. Think so. Okay, raise your hands. Up to now, everything is very clear. Hands up. If you understood what is linear momentum, what is change in linear momentum, if you understood, please raise your hands, everyone, quickly. Understood. Understood. Not difficult, right? Not difficult. Quickly write down until here. Now I will take the simple m as my common factor. I will take simple m as my common factor. Then I can write down this change in linear momentum delta p means mass simple m v minus u v minus u v minus u v minus u. Right? This is the change in linear momentum. Okay. I think now board is all right. Can someone confirm whether board is okay or not? Now my profile is from Nasmia Ali. That is the profile. I think both are my profiles. Reply to that. Huh? Now reply. If everything is fine, just put a reply. Now is it okay? Great. Great. Okay. It's okay. Now sample question number 2 write down. Sample question number 2 write down. Sample question number 2 write down. Write down. A car of mass 500 kilogram. A car of mass 500 kilogram was moving with a constant velocity. Was moving with a constant velocity. A car of mass 500 kilogram was moving with a constant velocity. Constant velocity of 10 ms minus 1. Of 10 ms minus 1 to the right side direction. To the right side direction. Of 10 ms minus 1 to the right side direction. Sometimes later, it is noticed that car is moving with a velocity of car is moving with a velocity of car is moving with a velocity of 50 ms minus 1, 50 ms minus 1 in the same direction. In the same direction. In the same direction. Roman number 1 write down. Roman number 1 write down. Find the initial linear momentum. Roman number 1, find the initial linear momentum. Roman number 2, find the final linear momentum. Roman number 2, find the final linear momentum. Roman number 2, find the final linear momentum. Roman number 3. Roman number 3, find the change in linear momentum. 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 It won't take more than 2 minutes. Once you finish doing the question, once you get in the answer, I want you to raise the hands, okay? Raise the hands. Now we are learning what is linear momentum, what is change in linear momentum. Then we can go to Newton laws. If you finished, if you got the answers, then raise your hands. Then only I can understand, okay, these guys finished, then time to explain them. Okay. Now this chapter is very important chapter. Now this chapter we are doing plenty of questions. Because we should do lots of questions. So you understand. Now this tute also contains so many questions. Without knowing the forces and Newton laws, you are not able to understand work energy power, conservation of energy, conservation of linear momentum, and torque, rotational motion, circular motion, hydrostatics, fluid dynamics. A very basic question. Mass is given as how much? 500 kilograms. Simple limb, 500 kilograms. Then initial velocity of the car is how much? How much? 10 ms minus 1. That means capital U, because U represents initial velocity. That is 10 ms minus 1. Final velocity of the car is 50. 50 ms minus 1. 50 ms minus 1. First, they are asking us to find the initial linear momentum, Roman number 1. Initial linear momentum, we know the equation. Linear momentum means always mass into velocity. Capital P means always mass into velocity. So I write down initial linear momentum as P1. Normally we use capital P1 symbol represent initial linear momentum. Capital P1 equals mass 500 kilograms, velocity 10 ms minus 1. Finally, I'm getting an answer 5,000. 5,000 units of linear momentum. We know kg, ms minus 1. You must keep your units. You must keep your units. Then what is the direction? What is the direction of linear momentum? Always mention the direction of linear momentum, because linear momentum is a vector. Direction of linear momentum will be right side direction. Right side direction. Always mention it. If you didn't mention that, mention it. Okay. Now Roman number 2. Roman number 2, what they are asking? Roman number 2, they are asking us to find the final linear momentum. Very basic substitution. We are starting from easy questions, but we are ending with difficult questions. That's the approach. Okay. Again, linear momentum means mass into velocity. Capital P2. Final linear momentum is capital P2. Mass is 500 kilograms. Velocity, final velocity V, final velocity 50. 50 means I'm getting around 3 zeros. 5 into 5 means 25. 25,000 kg ms minus 1. Direction of final linear momentum. What is the direction of final linear momentum? Same as right side direction. Same as right side direction. Then you know that Roman number 3, they are asking what is the change in linear momentum. Change in linear momentum. We just now we learned that change in linear momentum means final linear momentum minus initial linear momentum. So therefore we can write what we can do. Roman number 3, what we can do. If they are asking us to find the change in linear momentum delta P, Delta P means we know P2 minus P1. Delta P means P2 minus P1. Delta P, delta P, final momentum P2. P2 means 25,000, right side direction. Mention the arrow because upcoming questions you understand how arrow is important. If you fail to put the arrow, sometimes your answer can be wrong. Next sample question, you understand the importance of arrow. P2 means 25,000, right side direction, minus, we will learn relative motion also parallelly with forces, okay? Minus P1 means initial linear momentum P1, that is how much? That is also 5,000. That is also 5,000 direction, right side direction. Remember, I will tell you a law. There is a law. There is a law, I think in all levels also you learned. That law says that if you want to follow addition or subtraction, if you want to follow addition or subtraction for vectors, if you want to follow addition or subtraction for the vectors, remember those vectors must be in the same direction. Okay. If you are following addition or subtraction for vectors, those vectors must be in same direction. Then only you can subtract. Then only you can add. In vectors, I told you this idea. For an example, I tell there is a velocity vector, there's a force vector, 5 Newton force vector, right side direction. And there is another force vector that is 10 Newton. These are the two force vectors acting on an object. Okay. Now, there are two forces acting on the object, 5 Newton right side direction, 10 Newton left side direction. I'm asking you to add these two. I'm asking you to add these two. There's an object, 5 Newton force acting right side direction, 10 Newton acting left side direction. I'm asking, please add these two. Can you add like this? 5 plus 10 means 15. We can't do that, right? Right? Because why? Directions are different. Directions are different. Then we can't add like 5 plus 10, 15. We can't do that. Even though if you write a simple plus, we can't add 5 plus 10, 15. We can't do that. Why? Arrows are in opposite direction. But remember, if arrows are in same direction only, you can add them. Always understand, if you are following addition or subtraction, arrows must be in the same direction. Now, in this case, vector 25,000 right side direction minus vector 5,000 right side direction. Arrows are in same direction. If arrows are in same direction, you can subtract as usual way. 25,000 minus 5,000 means 20,000. Therefore, change in linear momentum will be 20,000 kgms minus 1 in the right side direction. Raise your hands, how many of you got the change in linear momentum mass 20,000 kgms minus 1 right side direction answer? Right side direction? Okay. Now, sample question number 3. Sample question number 3. If not, we'll do like this. We'll do the continuation of sample question number 2. Okay. Continuation of this question. Continuation of this question, write down. Okay. Continuation of this question. Okay. Now, Roman number 1, Roman number 2, Roman number 3, Roman number 4. Roman number 4, write down. Roman number 4, write down. Roman number 4, write down. Suppose what did we write the question? Suppose, bro, show me the question. So we wrote a car of mass 500 kilogram was moving with a constant velocity of 10 ms minus 1 to the right side direction. Sometime later, it is noticed that the car is moving with a velocity of 50 in the same direction. Write down, suppose if that car is moving to the opposite direction, of initial motion. Suppose if that car is moving to the opposite direction of initial motion. Roman number 4, okay? Suppose if that car is moving to the opposite direction to the initial motion, comma, find the change in linear momentum, find the change in linear momentum. Find the change in linear momentum. Now I will give you an idea. Now see now, previous question, this car initially moved in the right side direction with 10 minutes minus 1. In this question, I told you, finally it is moving with 50, but in the right side direction. But this time, what you want to do is, Roman number 4, what you want to do is, now think final velocity is in the left side direction. Think final velocity is in the left side direction, then find the answer, find the change in momentum. Think final velocity is in the left side direction, 50 ms minus 1, and find the change in linear momentum delta p. Raise your hands. How many of you got the Roman number 4 question answer? How many of you have the idea answer? Idea? How many of you have the idea answer? Online people, if you have the idea answer. What I'm saying, if you understood answer. What to be done answer. I'm telling same question, repeat the same question, only difference is final velocity is in left side direction. Then I want you to do delta P. Okay? Delta P. Better you also write at least the questions. Okay? Find the answer. Now focus, okay? Focus everything. Now we started around, I think 9:30 we started. Focus, huh? It's okay, you missed something, but from now onwards, now from these ideas, try to focus and try to get something. But then the next time you can easily catch it. Okay. Okay. Now if I do Roman number 4, if I do Roman number 4, I'm erasing this side. I'm erasing this side. I'm erasing. I'm erasing. This section is very beautiful section, right? I don't know how to teach you interestingly, but I know how to teach you clearly. I have that confidence. Roman number 4. Fourth one, they are asking now to find the delta P. Okay. Now, delta P means we know as usual, P2 means final linear momentum minus P1 means initial linear momentum. Delta P means P2 minus P1. Final linear momentum minus initial linear momentum. Now, final linear momentum mass is same as 500 kilograms. Final velocity is same as 50 only. But the thing is, 500 into 50 only, the thing is, a direction of final linear momentum is in the left side direction. Direction of final linear momentum is in the left side direction. So therefore, P2 means 25,000 in the left side direction minus P1 means initial linear momentum. P1 initial linear momentum 5,000, but as usual, direction is right side direction. P1 is 5,000, right side direction. How can I find delta P now? I told you, if you want to follow addition or subtraction among vectors, directions must be in the same direction. Always remember, if you want to follow addition or subtraction between two vectors, their directions must be in same direction. But the problem here is, yes, you want to subtract 25,000 minus 5,000. But the problem is you can't do a 25,000 minus 5,000 means 20,000. You can't do like that. Why? Arrows are in different directions. Arrows are in different directions. It's a problem. It's a problem. So therefore, you can't subtract in the usual way. Arrows are in a different direction. Therefore, you can't subtract in the usual way. Then what can we do now? Somehow you want to make arrows in same direction. Somehow you want to make arrows in same direction. I taught you this idea in vectors. I explained this idea in vectors. I told you, look here, if there is a vector, careful listen. If there is a vector, let's say vector A in left side direction. Can you remember vector A in left side direction means equal to minus vector A in right side direction. I taught you something like this in vectors. For an example, let's say there is a vector right side direction 500 Newton. This vector is equal to left side direction minus 500 Newton. This idea I explained in vectors. Refer the note, then you will get the idea. If not, there are recordings, you can check with the platform. So what I am doing now, I thought of writing this right side direction 5000, this vector. I thought of writing this right side direction 5000 kg ms minus 1 vector as like this. It is equal to right side direction 5000 means left side direction minus 5000 kg ms minus 1. So what I am doing here again, a 25,000 left side direction minus 5,000 right side direction means 5,000 right side direction means minus 5,000 left side direction. Minus 5,000 left side direction. See, every point is important. Learn. If you got wrong also okay, but every question learn something. Don't think linear momentum means P equals mv, change in linear momentum means P2 minus P1, theory finished. No, theory is not finished. Every question, what you do, you learn the theory. So therefore, learn from every question. Now what can I do now? Now these two are in same direction. Now I can simplify in usual manner. 25,000 minus into minus, that is plus. Minus into minus plus. That's a multiplication. And then we can write down 25,000 left side direction plus 5,000 left side direction. All together I am getting 30,000 delta P, change in linear momentum means 30,000 left side direction kg ms minus 1. Raise your hands. How many of you got this answer, correct answer? Online people, how many of you got this answer, correct answer? Most of you got correct. Then okay, then you got the idea. Okay, that's great. Then great. Then great. Okay. Right. Then now put your subtopic, not subtopic. Okay. Now there is another idea called rate of change in linear momentum. Write down rate of change in linear momentum. Write down rate of change in linear momentum. Rate of change in linear momentum. Linear momentum. Okay. Listen carefully. I can explain like this. Now let's say, look here. In this scenario, actually, this object is moving in a motion. But we noticed this object's velocity is changing. Am I correct? We noticed this object's velocity is changing. I see this object is undergoing acceleration. Think it is accelerating? Velocity is increasing, velocity is increasing. This object's linear momentum also increasing. That means this object's linear momentum changes with the time. Within simple t time, if not within delta t time, right? The change in linear momentum, P2 minus P1, that is delta P. Am I correct? Within simple t time or within delta t time, the change in any momentum of the object is final momentum P2 minus P1, that means delta P. Right? Remember, very carefully listen. Within delta t time, within this much of time, within 5 hours, change in any momentum means 10,000 something. For an example. Then, within 1 second, what is the change in any momentum? Within delta t time, change in linear momentum is delta p. Then within 1 second, what is the change in linear momentum? That is what we call as rate of change in linear momentum. Do you understand? For an example, 50 chocolates, 20,000 rupees. One chocolate, how much rupees? That is the idea, right? 50 chocolates, 20,000 rupees. Then one chocolate is how much? I say it as X. Then you know how do you find X normally in all levels? 5 over 1 equals 20,000 over X, very costly chocolate. X means 20,000 over 4, over 5. You are getting one chocolate is around 4,000. That is daily milk. That much price? Toblerone. Toblerone, no? What? 800. Okay, however. That is the idea. Now, within delta t time, change in momentum is delta p. Within 1 second, what is the change in the momentum? That is what we call as rate of change in linear momentum. Therefore, remember what we can do. We can write down delta t over 1 must be equal to delta p over rate of change in linear. Don't worry, you will understand. When we do questions, you understand these things. So therefore, believe what I am saying and work it. All the previous chapters, what I told and how I explained, you understood, right? So when I subject this term, what I am getting? Rate of change in linear momentum means understand, always. Rate of change in linear momentum means understand. Understand. What? Delta P over delta T. You got it? What is delta P? Change in linear momentum. What is delta T? Change in time. Write down. Write down. So better we write on the equation. Better we write an equation. Rate of change in linear momentum equals rate of change in linear momentum equals change in linear momentum over change in linear momentum. An equation, huh? Rate of change in linear momentum equals change in linear momentum over change in linear momentum over change in time. Change in time. Change in time. Again, write the symbol. Rate of change in linear momentum equals delta P over delta T. Delta P over delta T. If you want to write down this, you can write down this also if you want to write down this. Now I will ask you one question. What is the units of rate of change in linear momentum? What is the units of rate of change in linear momentum? Delta P over delta T. What is the unit? Units of change in linear momentum means kg ms minus 1. Kg ms minus 1. Units of time means seconds. Then actually we are getting units of rate of change in linear momentum means, remember, kg m s minus 2. When this s goes to the numerator, kg m s minus 2. Write down the units of rate of change in linear momentum is the unit. Now you can write down these things, huh? But as a point, write down. As a point, write down. As a point, write down. The units of rate of change in linear momentum is the units of rate of change in linear momentum is kg ms minus 2. Kg ms minus 2. Okay. Kg ms minus 2. Okay. Story finished. We'll do one question. We'll do one question. Then we have the understanding about linear momentum, change in linear momentum, initial linear momentum, final linear momentum. We know what is this rate of change in linear momentum also. Now we have an understanding. So we are starting Newton laws with that understanding. So we'll do one last sample question. Now it's sample question number 4 or 3. Sample question number 4. Then write down. Sample question number 3. It's 1. 3. Write down. An object of mass, 10 kilogram, an object of mass 10 kilogram changes. An object of mass 10 kilogram changes its velocity from 10 ms minus 1 to 10 ms minus 1 to 20 ms minus 1 in the same direction within 2 seconds. Within 2 seconds. Within 2 seconds. Find the rate of change in linear momentum. Find the rate of change in linear momentum. Find the rate of change in linear momentum. Now find the answer. Find the answer. 1 hour finished. 1 hour finished. Find the answer and raise your hands once you finish writing. Find the answer. Time went fast. Okay. Okay, we'll go with the poll then. Now you might feel time went fast, but we'll go with the poll now. There are around okay. How many of you feel this 1 hour went so fast answer? Okay, three options. As usual, 3 options. Went so fast. Usual way, very slow, very slow.
how many of you say time went so fast, so fast, so fast? For the online people, time is going so quickly. I don't know why. But for the physical students, yawning, yawning, sleeping, sleeping. But generally, this is happening in opposite way, right? Normally, online people feel time is not going and oh, boring and yawning and sleepy because when we keep on looking at the screen. But for the physical students, normally, really only they yawn, they some of them sleep, but not like this. Me? There's something happening up and down. I don't know why it's like that. Maybe world is going to destroy. That's the reason. Am I correct? Because of that's the reason, right? Yes, that's why North Pole and South Pole is converting. I think little by little. Now, whatever the North Pole now is, not the North Pole. That is the South Pole. What the South Pole now is, not the South Pole. That is North Pole. World is destroying. I think. Ne? Okay. Right. Okay. Okay. Done. Okay. Finish. That is done. Then okay. Now what can we do now? Right. That idea we have. That idea we have. Uh, I send the tudes. Okay. I send the tudes. How many of you hands up? How many of you got these online people? Raise your hands. How many of you got this tute hands up? Anyone got this tute hands up? No one. Okay. Okay. Right. Okay. Then I will share the PDF. Then we can do questions. We can manage today. We can manage today. Shall we take a small break and come? Hands up on the break now. Need a break now? Do you need a break now? All of me will need a break now, hands up. They don't want. What about you? Don't want? Okay. Then what we discussed then? Before inertia, what have we done here? Okay. Now put your main topic. Again theory. Again theory, put your main topic. Put your main topic. Newton's laws of motion. Newton's laws of motion. Newton's laws of motion. Newton's law of motion. Is what what? என்னவா எனக்கு என்னது எனக்கு ஐஸ்கிரீம் இல்லை வா you don't do okay right okay okay write down uh okay write down under that subtopic inertia inertia. I don't know, you guys don't know how to pronounce it and how to write it because you guys not good in English like me. Ne? INER INER TIA inertia inertia. Is it inertia? Inertia. Then isn't it INER SHIY? Inertia. Main topic is inertia. Okay. Main topic is inertia. Right. Okay. Now this is important. Right. Okay. Now still we are developing theories. Still we can't do any questions in Newton laws. Still we can't do any questions. But today we will do. Today we will do questions. Today we will do. Now look here. A new concept. A new concept. Rotation is capital I. Inside the bracket, rotation is capital I.
Inertia. Notation capital I. Now, when you consider any object in the universe, remember they don't like to change their current state of motion. Let's say if an object is at rest, now you are sitting and you are listening what I'm explaining. So once you sit, actually you don't like to stand up, right? Let's say once you sleep, so do you like to wake up? You don't like, right? Very similar idea is there. Any object in the universe, they don't like to change their current state of motion. What do I mean by current state of motion? Whether object is at rest or whether object is moving under constant velocity or whether object is moving under acceleration or whether object is moving under acceleration. Listen, inertia means what? Idea very simple. Any object in the universe does not like to change their current state of motion. That is the kind of quality that all the objects have. That means objects resist to change from its current state of motion. Okay? If an object is at rest, this object likes to, if not wants to, stay at rest. Okay? This object does not like to start moving. Let's say now there's an object, that object is moving under constant velocity. There is an object, that object is moving under constant velocity. This object does not like to change its current state of motion. That means this object is moving its constant velocity. It does not like to reduce the velocity, or it does not like to increase the velocity, or it does not like to come to rest. If you want to make an object's current state of motion, we should do something external to the object. That is the idea, right? Objects does not like to change their current state of motion. In case, if you want to change an object's current state of motion, we should do something externally. We will understand what is that doing something external later. Write down, red color pen, write down. Red color pen, write down. After putting the topic inertia, red color pen, write down. Inertia is known as the reluctance of an object to change its current state of motion. Is current the what I told? Inertia is known as the reluctance of an object to change its current state of motion. Next point, write down. An object at rest. Next point. An object at rest tends to stay at rest. And an object under motion, an object under constant velocity motion, okay? An object under constant velocity motion tends to keep its tends to keep its tends to keep its constant velocity. Constant. Tends to keep its velocity constant. Okay, velocity constant. Velocity constant. Okay. Right. So now if I explain further of this inertia, if I explain further regarding inertia, subtopic write down relationship between inertia and mass. Subtopic relationship between inertia and mass. Relationship between inertia and mass. Okay. Now listen very carefully. Now we understand inertia means kind of property for an object which to resist its current state of motion. That means something like this. Inertia means a property belongs to any object. What is the idea? Any object does not like to change their current state of motion. If an object is at rest, object likes to stay at rest. If an object is moving, it likes to keep on moving. Let's say if you want to change an object's current state of motion, now I am at rest. I am at rest. Now, if you want to make me move, if you want me to move, but I am saying that I can't move. I like to stay at rest. But you want me to move. Then what you do? You come here and you push me. Then go like this. But then only I start moving. So that means I like to stay at rest and I'm staying at rest. But if you want to change my current state of motion, basically what are you doing? Reply. I'm asking from you. Now I am at rest. An object is at rest. That object likes to stay at rest. But you want to change that object's current state of motion. That means you want to make move that object. Then what would you do? You are applying an external force. See, that force comes. Without applying an external force, can you change an object's current state of motion? We can't change. Let's say an object is moving. Just think that train is moving under constant velocity. This train is keep on moving under constant velocity. Train is moving. You want to make the train stop. Then what you do? Again, you are providing an external force on the train in the opposite direction of the motion. That is the idea. That is the idea you should understand. Remember, this resistance to change state of motion depends on mass. Depends on mass. Also, this inertia is directly proportional to the mass. Larger mass objects have larger inertia property. For an example, let's say there are two masses. This one is simple limb. This is a very huge mass, capital limb. Now, initial state of motion of both the masses are rest. This one is also at rest. This mass, capital M, also at rest. Now, we understood if we want to change an object's current state of motion, we want to apply an external force. Now, tell me which object shows larger reluctance to change its state of motion. Which out of these two masses, which object shows the larger reluctance, larger resistance to change its current state of motion? Hands up, who says simple limb, hands up? Capital M, hands up? Capital M, right? Because when the mass is larger, understand, when the mass is larger, very difficult to move that object. Think a small stone and very huge rock. Can you easily move the rock? Now, when you provide, let's say when you provide 500 Newton external force, You could easily move the simple limb mass. You could easily move the simple limb stone. But if it's a huge rock, and if you even provide the same 500 Newton force, will you able to move the rock? Sometimes you won't. Actually, you won't. Even you apply 50,000 Newton force also, remember, sometimes you are not able to move the stone, move the rock. So therefore, understand inertia depends on mass. If an object's mass is high, that object's inertia high. Then I'll ask you a question. When mass is high, reluctance, resistance to change state of motion is high. That means inertia is high. If you want to change further its state of motion, the force that you want to apply is also high. Am I correct? Comparing with the force that you provide to change this object and the force you want to provide for this object is large, right? You understand? Hands up who understand what I'm saying. If you really understand, hands up. Online people also hands up if you understand what I'm saying. I think you guys have an idea. Don't worry, we will learn these things. I think you have an idea. Right. What you do, write down relationship between inertia and mass and write down. Next day, if it is possible, I will show you some videos. Then you understand some concepts. Okay, I'll show you some videos next day. Write down, write down, write down. When the mass of an object increases, when the mass of an object increases, when the mass of an object increases, comma, comma, the inertia of the object, the inertia of the object is also increases. The inertia of the object is also increases. The inertia of the object is also increases. So write down this example. Write down, now there are two masses, simple limb, capital limb. Now there are two masses, simple limb, capital limb. So we know capital limb is larger than simple limb. I say inertia of simple limb mass I1, inertia of capital limb mass I2. Large the mass means large the inertia. Therefore, we know I2 is larger than I1. If you want to write the simple limb, capital limb masses, I1, I2, inertia. I1 means inertia of simple limb. I2 means inertia of capital limb. Write down this. So also write down this inertia is directly proportional to mass also. Also write down this relationship also. Okay. When mass is larger, inertia is also larger. Inertia is also larger. This one. Okay, this one. Okay. Okay. Write down. Now we understand who is the external factor. Who is the external factor which changes an object's current state of motion? Listen this carefully. There's an object, mass simple limb. This object is at rest initially. That means current state of motion is rest. Okay. I say corresponding inertia of this object, reluctance is I1, in front I. This object is at rest. It likes to stay at rest. I want to change this object's current state of motion. That means this object is at rest, but I want to move this object. I'm asking, then who is the external factor? Who is the external factor which changes an object's current state of motion? The force. Remember, the external factor which changes an object's current state of motion is the force. I will explain what is force later, but all level knowledge, you know what is force. You have an idea. The external factor which changes an object's current state of motion is force. Without applying a force, you are not able to change an object's current state of motion. If you are changing an object's current state of motion, you want to apply force. That is the idea. That is the idea. Write down red color pin. Write red color pin. If an object's current state of motion is to be changed, write down. If an object's current state of motion, if an object's current state of motion is to be changed, then the external factor, then the external factor acting on the object is the external force. Acting on the object is the external force. Blue color pen, write down. An object's current state of motion cannot be changed. An object's current state of motion cannot be changed. An object's current state of motion cannot be changed. Cannot be changed without applying an external unbalanced force. Without applying an external unbalanced force. Okay, now we can start Newton laws. Okay, now I will bring all of them together and I will explain at the end. Okay, now we are developing little by little. Now in Newton laws, there are three laws: Newton's first law, Newton's second law, Newton's third law. Newton's third law, I think, very easy. I'll ask from you, what's Newton's third law? Every action has an equal opposite reaction. Everyone knows. It's not like it's more than a third law, right? So everyone knows that. But remember, out of these three laws, the most critical law, the law we used to do all the questions in the unit is Newton's second law. Newton's second law is the most important law. Newton's first law also important, but relatively second law, first law is not that much important also. Red color pen, write down Newton's first law. Newton's first law. Newton's first law. Time is 11 o'clock. Need a break. Newton's first law. Write down red color pen. When you are writing, understand, write down. I say, when you are writing something, understand, write down. Red color pen, write down. Red color pen. Unless an external unbalanced force, unless an external unbalanced force acting on an object, acting on an object, comma, comma, object continues to be at rest or object continues to be at rest or moves with constant velocity, moves with constant velocity, moves with constant velocity. Highlight, highlight, unbalanced external force, highlight unbalanced external force, at rest, constant velocity, at rest, constant velocity. Now look here. Now Newton is telling, now Newton is observer. Newton is a good observer. He was a good observer. Now, after observing the motions, he came to a conclusion. He is telling that the law. Law means we can't argue because law means universal truth. Okay, law means universal truth. We can't argue. Newton told is wrong. We can't tell like that. It's a law. It's a law. All we accepted it is correct. Newton is telling if there is an object, if there is no any external forces acting on the object, then there are two possible states of motion. One is either object should be at rest, if not, object should be moving under constant velocity. If not, object should be moving under constant velocity. Again, I say that Newton is telling that until if there is no any external force acting on the object, no force acting on the object, there are two possible state of motions for an object. This object must be either at rest, if not, this object should move under constant velocity. Then we can go with the opposite way also. Whenever you notice an object is at rest or an object is moving under constant velocity, what is the conclusion? What is the conclusion? There is no any resultant force acting on the object. See? So you should be able to think forward and backward both ways. Newton is telling when there is no external force acting on the object should be at rest. If not, definitely object should move under constant velocity only. If you are going backward direction, whenever in a question, if you see that object is at rest, if not the question, when you see that object moves under constant velocity, remember, the conclusion is there is no any external force acting on the object. I'll ask you a question then. Now this object is moving under acceleration. There is another object moving under deceleration. Raise your hands, how many of you say there are external forces acting on the object? Hands up. Whenever you see an object moving under acceleration or moving under deceleration, raise your hands, how many of you say there should be external forces acting on the object? There should be. Because if there is no external force, there is only two possibilities. The object must be at rest. If not, object must be moving constant velocity. If you notice an object is moving under acceleration or deceleration, remember, there must be an external force. Keep these things in your mind. Keep these things in your mind, okay? Right. Okay. Now subtopic. Based on this law, a definition about the force can be defined. Subtopic. Definition of force. Definition of force. Write down. Write down. The physical quantity which changes. The physical quantity which changes. The state of motion of an object. The state of motion of an object. The state of motion of an object. The state of motion of an object is defined as force. Is defined as force. Is defined as force. Red color pen, force is a vector. Red color pen, force is a vector. Force is a vector. If I repeat it again, the physical quantity, I told you what? The physical quantity which changes the state of a motion of an object is known as force. Red color pen, force is a vector. Okay? Done? Shall we brief it? Shall we brief what we learned so far and shall we brief it and we'll take a break? Okay? I need a break also. Now time is 11:05. We'll take a break. Okay? We'll take a small break and come. Now, sometimes you guys think that I am taking so much time and I'm explaining this, but you know that now when I explain this idea, you think, this is the idea, right? Why this guy is repeating same thing? But when you do question, you understand what I am telling. Ne? When you do questions only, they understand what I am telling, right? So I will brief it. Today, what have we done actually? We started, actually today the topic is Newton laws and forces, right? Then we started from linear momentum. Linear momentum is a physical quantity, mass into velocity. When you multiply mass by object's velocity, that is linear momentum. It's a vector, unit is kg ms minus 1. Then we discussed about what is this change in linear momentum. Then we talked about what is this rate of change in linear momentum. Now we have a good understanding about those things. Then we shifted to inertia. Inertia means we understood any object does not like to change its current state of motion. That means all the objects show kind of reluctance to change their state of motion. That property of the object we called as inertia. Inertia depends on the mass. Larger mass have larger inertia, smaller mass have smaller inertia. Then we talk how inertia relates with force. Let's say if we want to change an object state of motion, who is the external factor? The force. And also, then we talked about what? Newton's first law. Newton told what? If there is no external force acting on the object must be at rest. If not, object must be moving under constant velocity. In a question, when you see an object is at rest, an object moves under constant velocity, you can tell what? There is no any resultant force. Okay? Then you can tell, then if no force means rest or constant velocity. If there is a force, then object should accelerate or decelerate. That is the idea. That is the idea you learned up to now. Now we can take a break. After the break, we'll start what is this Newton's second law. We'll derive the equation F equals ma. From that, we'll start doing tude questions. Then we'll stop little after doing few questions. We'll stop the Newton laws. We'll go back to motion graphs and we'll do few questions. Then class will be finished. What is the time exactly now? Reply. How long you guys want? Online people. How long you guys want? Time is 11:05. Reply quickly. How long?
Our Aisha, how long you want? Anything is fine. Online people, how long you want? 15. Okay, I am giving reply, quick reply, everyone. Reply. Reply. Only one is replied. Reply to those that Nasmia, you want to reply to what account? Nasmia Jaufar. Reply to that Nasmia Jaufar account. Huh? How long you guys want? 11, okay, 15 minutes. Okay, oh, most of you saying 15 minutes. Come at 11:20 to 20. Okay, come at 11:23. Come at 11:23. 11:23. Take a break and 11:23. Right. Okay. We'll start again. Okay. Now we finished under studying Newton's first law. Put your subtopic. Put your subtopic. Put your subtopic. Newton's second law. Newton's second law. Subtopic Newton's second law. Red color pen write down. Red color pen write down. The rate of change of linear momentum. Red color pen write down. The rate of change of linear momentum. The rate of change of linear momentum of an object is directly proportional to the is directly proportional to the is directly proportional to the magnitude of the external unbalanced force, magnitude of the external unbalanced force, magnitude of the external unbalanced force acting on the object, acting on the object, acting on the object. Now Newton's first law says when there is no any external force acting on the object, object must be at rest. If not, object must move under constant velocity. Newton's second law says that when there is an external force acting on the object. Newton's first law is saying when there is no external force, Newton's second law says that suppose if there is an external force acting on the object, then let's say now there is an object. Now this object mass simple limb. Initially I say velocity of this object is capital U. But understand now there is an external force acting on the object. Capital F external force acting on the object. Then tell me, what would happen for the velocity of this object? If there is an external force acting on the object, we know that will this object move under constant velocity with U? If there is external force capital F acting on the object, will this object continue moving with same velocity U? It can't. Velocity should be changed. Am I correct? Can be increasing or decreasing. Now we'll think because of this external force applied on the object, what's happening? Velocity of the object is changing. I say after simple t time later, now velocity of this object is capital V. Now velocity capital V, but still the same external force is acting on the object. Still same external force acting on the object. Okay. Then we noticed velocity of the object changed continuously. Why? Because of the external force applied on the object. Because of this external force applied on the object, when velocity changes, linear momentum also changes. Why? We know linear momentum means mass into velocity. Linear momentum means mass into velocity. If because of this external force, if velocity changes, definitely linear momentum also changing with the time. See the things that we learned earlier, how it sinks.
Then Newton observed this. When there's an external force, Newton observed linear momentum of the object also changes. And Newton told that external unbalanced force acting on the object is directly proportional to the rate of change in linear momentum. Now you can remember what is rate of change in linear momentum? Change in linear momentum over change in time. That is what I explained as rate of change in momentum. Newton told that when there is an external force acting on the object, linear momentum of the object changes, that external force directly proportional to the rate of change in linear momentum. Now they are doing this experiment further, right? To remove this proportionality, we can remove this proportionality by using a constant. Am I correct? It's a proportional symbol. We can remove this proportional symbol and we can put equal symbol. Then you have to put a constant k. Then we got an equation f equals k delta p over delta t. And experimentally found that this k value is exactly 1. Experimentally found k value is exactly 1. Then we got a final equation. External unbalanced force acting on object is not only directly proportional to rate of change in linear momentum. Remember, external unbalanced force is exactly equal to rate of change in linear momentum. In the previous theory, we wrote rate of change in linear momentum. What is rate of change in linear momentum? That is the force. Another name for rate of change in the momentum is, remember, that is the force. Force is what we call as rate of change in the momentum. This is the very important equation in the lesson. Okay, I will once again brief it. I know I'm repeating same thing again. Once again, I'll brief it. Newton's first law said that if there is no external force, object should be at rest. If not, object should move under constant velocity. Right? If there is external force acting on the object, we know that velocity of the object should be changed. Let's say because of this capital F external force, velocity of this object is increasing. Now V is larger than U. Right? Then Newton further telling this external force exactly directly proportional to rate of change in linear momentum. Now I think that you guys know what is rate of change in linear momentum. And then I remove this proportionality. Then I put equal and a constant. That is how we remove proportional symbol in maths. If you want to remove proportional symbol, you want to put equal and you want to put a constant. Then finally, they found this k value is exactly 1. Then the conclusion is external unbalanced force acting on the object means the rate of change in linear momentum. But you guys not familiar with this equation. You guys familiar with F equals ma, external unbalanced force equals mass into acceleration. You guys familiar with this equation, but remember, this is this equation. How many of you can see? Look here, I'll ask a question. How many of you can see when you look at this F equals delta P or delta T? When you look at this equation, how many of you can see F equals ma here? Raise your hands. How many of you can see F equals ma? How many of you see when you look at here? This look like F equals ma, hands up. So I know all of you raise your hand, this look like F equals ma, but I want you to show from here to here. Start writing all this diagram and until here, come until here. I want you to derive F equals ma from this equation. I want you to derive F equals ma from this equation. Once you derived, raise your hands. If you derived, only raise your hands. Huh? Right until here, you know u, v, delta t time. Let's say if you want this object is undergoing acceleration also, derive this equation from this one. You need linear motion equations also. You need linear motion equation also. I think you guys came to linear motion. Derive it quickly. Derive it. Derive it. You got it, bro? What is this? This is okay. This is okay, but you want to derive from those symbols. Involve u and v and go with the linear motion. Oh, it's correct, but should go with linear motion equation and involve them. Involve them. If you derive, hands up. If you derive, hands up. Start from this one, get this one. This is this. This is this. Derive it. Start deriving. Don't waste your time. Start deriving. Anyone finished, hands up? If anyone finished deriving, raise your hands. Okay, need some time, sir. Give some time, hands up. If you need some time, hands up. Okay. Done? Did you include V and U? What is the equation? Ah, that's it, right? Easy, right? Very basic. Very basic. But you don't know what is linear motions, right? Next week we will learn in Saturday class. Okay? Saturday we will learn. So you can remember linear motions. Linear motions, we learned an equation. Linear motions, we learned an equation. V equals u plus at. V equals u plus at equation. From this equation, final velocity is v, initial velocity u, acceleration a times simple t. Now I am subjecting this time, delta t time. Sorry, I am subjecting simple a. If I subject simple a, we know we are getting simple a means, remember, v minus u over delta t. V minus u over delta t. I write down this as equation 1. This is equation 1. Now I am continuing from this equation. We obtain important equation F equals delta P or delta T. External unbalanced force means rate of change in linear momentum. Okay. Now this is change in linear momentum. What we know about change in linear momentum? That is P2 minus P1. Therefore, I am writing this is final linear momentum P2, initial linear momentum P1. We learned delta P means, you guys know, it's P2 minus P1. I can write down it as P2 minus P1 over delta T. That is capital F. Am I correct? Now you know P2 means final linear momentum. Final linear momentum means, you know, linear momentum means mass into velocity. Final linear momentum means mass into final velocity. P1 means initial linear momentum, mass into initial linear velocity. So what can I do? I can use these things here. I can write on capital F equals, then P2 means MV, P2 means MV minus P1 means MU time is delta t. I can take simple m as my common factor. Simple m as my common factor. Then I am getting f equals simple m v minus u over delta t. This is my equation 2. Look at the equation 1. Equation 1, v minus u over delta t means a, acceleration. Look at the equation 2, v minus u over delta t. So what can I do? This v minus u over delta t means what? V minus u over delta t means what? That is the a, right? From equation 1 and 2 I am writing. From equation 1 and 2 I am writing. 1 and 2 I am writing. Therefore, f equals simple m, v minus u delta t means that is the acceleration a. This is how we get f equals ma equation. This is how we get f equals ma equation. Raise your hands. Up to now, everything is crystal clear answer. Up to now, everything is crystal clear. Raise your hands. Okay. Now it's time to do some questions. We'll do questions. You don't know linear motion, you will understand. Okay, next week we are starting. Huh? Then I will share a PDF. I send the tudes. I will share a PDF. I will share a PDF. Give me 1 second. In that PDF, I will share in the group. I'm sharing in the group. Huh? Yes, shared. So please download that PDF in the group. Just shared. Yes. Now page number in the tute. This is the tutor. I send the tute. Open page number. Page number. Page number 2. Question number 5, 6. Start doing question number 5, 6. 5, 6, 9, 10, 11. 5, 6, 9, 10, 11. Start doing 5, 6, 9, 10, 11. Start doing. Keep on doing. 5, 6, 9, 10, 11. 5. After then 6, 9, 10, 11. Raise your hand. Started doing question number 5 answer. Started doing question number 5 answer. Started doing question number 5. Started doing 5 answer. Started doing 5. Okay. I'm also doing 5. 5 is not difficult. 5 is a basic question. It says that what is the resultant force required to give a 2 ms minus 2 acceleration for a mass of 3 kilogram? There is a mass 3 kilogram mass. In order to accelerate this mass with an acceleration of 2 ms minus 1, 2 ms minus 1, 2 ms minus 2, what is the required external force? You can directly apply F equals ma equation. Find the answer. Find the answer. F equals ma equation. The force, capital F force. They are asking capital F. So then when I apply F equals ma, standard equation, you can apply equation F equals ma. F equals ma in the direction of motion. I'm applying F equals ma in the direction of motion. Object is moving right side direction. This equation is applied also in the right side direction. I want to find capital F. I want to find capital F. Mass how much? Mass is 3 kilograms. Acceleration is 2. 3 into 2 means 6 newtons. 6 newtons. Red color pen write down. Red color pen write down. The units to measure force is newtons. Red color pen. The SI units to measure the force is newtons. The SI units to measure the force is newtons. The SI unit to measure the force is newtons. Next point write down. Red color pen. Apply F equals ma equation. Apply F equals ma equation always in the direction of motion. Apply F equals ma equation always in the direction of motion. It means vectors in the direction of motion. It means vectors in the direction of motion are positive, and the vectors in the opposite direction of motion, and the vectors in the opposite direction of motion are negative. Okay. Now, you guys, if you came to the linear motion chapter, we always apply linear motion equations in the direction of motion. What is the meaning of that? If you are putting an arrow right side direction, what is the meaning? In the equation, if there are vectors, if those vectors are right side direction, if those vectors are in the arrow direction, the values are plus. If any vector in the equation direction is opposite to the arrow, they are minus. That is the idea I wanted to give here. You do this idea. When you do questions also, you understand this is what I meant. Okay, question of 5 done. I'm doing 6th one. Hands up who finished 9 hands up. 6 and 9 finished hands up. 6 and 9 finished hands up. 11 also finished hands up. 11 also finished hands up. I think all of them finished. 11 finished. These online people, they are working good, ne? They are working good. Okay. If you finish 11, then you just listen a song until we finish 11. Right. So I'm going to 6. Then I am the last one, I think now. All of them finished 11. I'm the last one doing, I'm doing the second question only. I think I am weak. Okay. Question number 6. 6 they are telling, what is the acceleration of an object when force 10 Newton applied to a mass 5 kilogram? This time 5 kilogram mass. They are asking us to find the acceleration. Applied forces 10 newtons. Applied external forces 10 newtons. 10 newtons. Again apply F equals ma. Again apply F equals ma in the direction of motion. This direction, F equals ma, then 10 Newton. 10. Mass is how much mass? Mass is 5 kilograms. Actually, I want to find the acceleration only. If I subject acceleration will be 10 over 5. 10 over 5 means 2 ms minus 2. 10 over 5 means we know it's 2 ms minus 2 acceleration. I found the answer. I also finished doing sixth one. Then I want to, I'm going with 9. I'm going with 9. I'm going with 9. Question number 9 says what? You did sixth one. Right? Write down. In the book, huh? In the book, write down. Yes. Ninth one, write down. Ninth one, a car which has a mass of 1000 kilogram. Car which has a mass of 1000 kilogram moves with an acceleration of 2 ms minus 2. Find the resultant force exerted by the engine. Find the resultant force exerted by the engine. If the resistance force to the motion is 1000, then find the force generated by the engine. Okay. I will tell this idea. Ninth one, I will explain this idea. I'm explaining this idea. Okay. Now there is a car. This is my car. What they are telling in the question? Mass is 1000 kilograms, simple M 1000 kilograms. Then they are telling this car is moving with acceleration 2 ms minus 2. I say acceleration of the car, acceleration 2 ms minus 2. Then what is the, look here. Now stop doing and look at here. Whenever you see an object is accelerating, what is the conclusion? Whenever you see an object is accelerating, what is the conclusion? There must be a resultant force acting on the car. There must be an external unbalanced force, right? I hope you understand. There must be a resultant force, unbalanced force. Now, vectors, now because I am teaching you this idea, thinking, assuming you guys have the vector knowledge. Can you remember vectors we learned, resultant vector? Look, stop doing, look at it, stop doing, look at it, stop, okay, I know, you guys can do this one. Stop doing, look at it. Now, I will ask you a question. Online people also raise your hands. There's an object. Now, external force 5 Newton applied on the object right side direction. 5 Newton applied on the object left side direction. There are two forces. My question is, raise your hands, how many of you say, raise your hands, how many of you say, this object undergoes acceleration, hands up. Raise your hands, how many of you say, this object undergoes acceleration, hands up. This object is not accelerating, hands up. This object not accelerating, hands up. This object is at rest, hands up. This object must be at rest. This object must move under constant velocity, hands up. This object must move under constant velocity, hands up. Look here. Now that Newton is telling, always Newton is telling, external unbalanced force, external unbalanced force. You know what is the meaning? The meaning is resultant force. Okay, someone can tell, sir, now according to what you taught us, when there are forces acting on the object, this object must accelerate, right? One can ask a question like that. Sir, you taught us when there is no external force, object is at rest to move under constant velocity. You taught us when there are forces, object must accelerate, right? That is how you taught us. Now in this case, there are forces. Then why you are telling this object is at rest? Why this object is not accelerating then, sir? You can ask like that. But I told you, every time when we wrote that external unbalanced force. That means resultant force. Now, in this question, in this case, yes, there are forces. Yes, there are forces. But what is the resultant force acting on the object? 5 Newton right side, 5 Newton left side. Resultant is 0. 0 resultant force. That means your external unbalanced force is 0. That means it like no resultant force. Then this object can be at rest also. This object can be moved under constant velocity also. Some people think like this. Some people think since the childhood, some people think if there are no forces, object must be at rest. That's how they're always thinking. That's also wrong. If there is no external forces, object can be at rest. Also, object can move under constant velocity. Don't forget that. If I ask you if resultant force is 0, what is the state of motion? You guys telling object is at rest only. Newton also told that object can be at rest. If not, object can also be moved under constant velocity. Don't forget to do that. Now, in this case, we don't know how many forces acting on the object. Look here. Now, in this question, we don't know actually how many forces acting on the object. We don't know. Now think practically. Think practically. This car is moving. If this car is moving, engine has to provide. Now, who provides the force? If this car moves forward direction, we know that there must be a force acting on the car forward direction. Who produces that force? There is an engine. Engine burns petrol in the engine. During burning, heat is generated. There will be a force produced by the engine. Because of that engine force only, we know that car is, because of that force produced by the engine only, we know that car is going forward direction. Okay. So therefore, I'm marking the force produced by the engine on the car forward direction. I put it as FE. E for engine. Force produced by engine on the car, FE, forward direction. Now, this car is going on the road, right? This car is going on the tar road. What is the we call in English tar? Tar. Asphalt. Whatever the road. The car goes on a road. When this car is going on the road, some kind of friction, some kind of resistance to move the car on the road. Am I correct? When this car is moving, always remember there is kind of resistive force acting on the car backward direction. Right? Remember, if a car is moving in a motion, engine produces the force FE forward direction. Look here. There will be a force acting on the car backward direction. That is the resistive force FR. R for resistive force. Okay. I will ask you one question. Still, now there is only two forces. Think in that way. There is a force produced by engine forward direction, resistive force backward direction, but they mention car is accelerating. They mention car is accelerating. I am asking, what is the right inequality between FE and FR? What is the right inequality between FE and FR? Out of these three options, now first option says that engine force, if car is accelerating forward direction, engine force must be greater than resistive force, option 1. Option 2, engine force and resistive force both are same. Option 3, engine force must be less than resistive force, option 3. So I want your attention, your support also. Raise your hands, how many of you say the right inequality is option 1 answer? Raise your hands, how many of you say FP must be greater than FR answer? That is the obvious truth, right? If this engine force is greater than FR, only car can go forward. For an example, not related to this question. For an example, I tell engine force is 500 Newton for an example. Then resistive force should be 100 Newton something. Okay. Okay. Then I'm asking, what is the resultant force acting on the car? I'll ask from you. What is the resultant force acting on the car? One force is acting forward direction 500, other force acting backward 100. What is the resultant force acting on the car? 400 Newton forward direction. Always you guys remember F equals ma equation. F equals ma equation. F means remember the resultant force. If you want to write it also, remember always F means the resultant force acting on the car. In F equals ma equation, always try remember F means the resultant force. I think now you can do it. Hands up who finished doing this question answer. Question number 9 finished answer. 9 finished. 9 finished. 9 finished. Now I am doing, they are asking resultant force. First they are asking find the resultant force exerted by the engine. Resultant force. First they are asking resultant force. So now actually I don't know what is engine force, and also I don't know what is resistive force. I want to find the resultant force, resultant of Fe and Fr. I know resultant force is this direction, capital F. F equals ma equation, F means resultant force. Therefore, what I am doing, I am applying F equals ma. For the car, I am applying F equals ma in the direction of motion. Then F means always, F equals ma equation, F means always resultant force. Resultant force must be equal to mass. Mass how much? Mass 1000 kilograms. Acceleration is 2 ms minus 1, minus 2. Then the resultant force will be 2000 newtons. This is the resultant force. Resultant force. Okay. Then they are telling, they have given, if resistive force is 1000. Then they are telling, if resistive force is 1000 Newton, then find the force produced by engine. Then they are asking, find the force produced by engine Fe. Did you find the answer? How much? Then we know, I know the resultant force. Shall we write an equation involving resultant force Fe and Fr? We know that Fe minus Fr is resultant force F. We know that resultant force means Fe minus Fr. Resultant force I found as 2000. Resultant force I found as 2000. Force produced by engine, Fe. That's what I want to find actually. That's what I want to find actually. Fr is how much? Our time is 12.5. You got. Fr is how much? 1000. Then force produced by engine will be F equals how much? F equals 3000. Hands up who got correct? F 3000 hands up. Hands up who got F equals 3000? F 3000 hands up. 3000 Newton. I think most of you getting very good. But I am explaining for any level of student. Therefore, this is my way, right? Normally, I do this. It's my way. But if you really bright, then you keep on doing the question. Now, I have given only 11. You just try whether you can do any other question. Then you guys keep on doing. Don't wait until I finish something. Okay? Keep on writing. Start doing next question. Then after doing 10, 11 finished. If you finish doing 10 and 11, start doing question number 8. Start doing 8. Start doing 8.
Then 743. 8743. Question number 8743. Start doing 8. Start doing 8. 743. 8743. Now I am doing question number 10. I am doing question number 10. I am doing question number 10. So then question number, yes, question number 10, 10th one says that constant force acting on a body of mass 5 kilogram changes speed from 2 ms minus 1 to 7 ms minus 1 in 10 seconds. Direction of motion of the body remains unchanged. Find the magnitude of the force. Now look here, now question number 10. 10, initially I am drawing the diagrams and I am doing the question, but upcoming days I am not drawing the diagrams. Mass 5 kilograms. Mass 5 kilograms. Initial velocity. Initial velocity is 2 ms minus 1. Final velocity is how much? Final velocity will be 7 ms minus 1. This is u. This is v. U and v. And within 10 seconds, this gap is 10-second time period. 10 seconds time. What I want to find? I want to find the external force. Now see, now you can use any of the equation, but this time one can do what one student can do. You can apply linear motion equation because you know final velocity, you know initial velocity, you know time. One can find the acceleration and one can substitute to F equals ma equation. That is one method. If not, one student can apply this equation. So I am thought of applying this equation. In the direction of motion, I am applying. In the direction of motion, I am applying F equals delta P over delta T. Delta P means you know that final linear momentum minus initial linear momentum. Delta P means we know that final linear momentum means mv minus mu over delta T. That is capital F. Then capital F means we know that simple M. Okay, v minus u. Now I am following all the steps, but you don't want to follow all the steps. So mass is how much? Mass is how much? Mass 5 kilograms. Final velocity is 7 minus initial velocity is 2. Time taken is how much? Time taken is 10 seconds. That is capital F. Then capital F will be equal to, I can divide, see. 5, 7 minus 2 means how much? 7 minus 2 means 5. 5 into 5 means 25. 5 into 7 minus 2 means 5. 5 over 10. Then here I can divide by 1. For the 10, there are 2 5s. Finally, I am getting 5 over 2. 2.5. That's my answer. Question number 10 also done. See, very easy. In exams also, there are some MCQs coming like this. Very, very easy. I should write down. Write everything. Next one, question number 11. Next one, question number 11. Question number 11, what they are saying? 11, they are telling resistance force of 100 Newton applied to a body of mass 50 kilogram moving with speed 20 ms minus 1. How long does the body take to stop? They are asking us to find the How long does the bullet take to stop? They are asking the time, ne? Now, at here, this is the object. Initial velocity is how much? 20 ms minus 1. Initial velocity 20 ms minus 1. This is 20 ms minus 1. My u is 20 ms minus 1. Now what happened? Look here. Now mass is how much? Mass of this object is how much? 50 kilograms. Mass 50 kilograms. Now they are telling this object is decreasing the velocity and this object comes to rest. If we want to stop this object, if we want to stop this object, if we want to reduce the velocity of this object, what direction you want to apply your external force? If you want to stop the object, what direction you want to apply your external force? Left side direction. Left side direction, right? If you now this guy is going like this. If you want to stop me, someone want to push, someone want to provide a force this direction, left side direction. So external unbalanced force is in left side direction. Left side direction. Capital F. Capital F. After some time later, object comes to rest. After some time later, this object comes to rest. That means I say I don't know the time. Now final velocity is 0. Initial velocity is 20. Velocity decreases. Final velocity is 0. I want to find the time actually. Did you find the time? I want to find the time actually. I want to find the time. How can I find the time? The time taken to rest from 20 ms minus velocity. How can I do this one? Now there are different methods. What can you do? One can find the acceleration. That means one can find the deceleration by applying F equals ma. Okay, look here. You also start doing apply F equals ma for this object. Apply F equals ma for this object and find the acceleration. That means negative acceleration. That means deceleration. Apply F equals ma and find the acceleration. You know mass. You know mass. The force you want to apply, they have given how much? F is how much? F is 100. You know force is 100. Then find the acceleration. If you apply F equals ma, find the acceleration quickly. Find the acceleration quickly. Find the acceleration quickly. Acceleration. Find the acceleration. Now I am applying F equals ma. Look here, always I am applying. Now everyone listen, okay? Apply it. Okay, keep on doing. Keep on doing. Finished, bro? Done? Finished? Yes. Answer, answer. If you finish doing 11th one, do remaining. Okay. Now I am applying F equals ma here. Always now you always learn the way how I am doing a question. Now I am always applying F equals ma in the direction of motion. We know this object is moving in the right side direction. Even though it's slowing down, object is moving in the right side direction. Therefore, right side direction, I am applying F equals ma. Now what is the problem? You know out now in this equation F equals ma, force is a vector.
Mass is a scalar. Acceleration is a vector. Force, what is the external unbalanced force acting on the object? Left side direction 100 Newton. I told you, red color pen, we wrote a point also. What is the point? Vectors in the direction of motion positive, vectors in the opposite direction of motion negative. Now I am applying the equation right side direction, but the force is in left side direction. Therefore, I am substituting here minus 100. See, if you follow with my way, how it's easy. How it's easy. Right? I am applying minus 100y. Force, equation applied right side direction, but force is in left side direction. Minus 100. Mass is a scalar, 50 kilograms. Acceleration means, I want to find it. I don't know acceleration. Then I am getting acceleration as minus 100 over 50 means minus 2 ms minus 2. Minus 2 ms minus 2. Why I am getting negative value? Because right side direction, it's a deceleration. I told you deceleration means negative acceleration. That's why we are getting minus 2. Now, if you want to find time, you know U, you know V, you know A, you want to find T. Linear motion equation, V equals U plus AT. If you didn't know what is linear motion equation, next week we are doing in a cover up class, Saturday 1 to 3. Right side direction, V equals U plus AT. My V, final velocity is 0. Learn from the questions. Initial velocity, right side direction, 20. See? Now see, I apply this equation in the right side direction. What is the meaning? Right side vectors are positive, left side vectors are negative. V is 0, my U is right side direction, they have a positive. Plus, acceleration is minus 2. Acceleration is minus 2, left side direction, minus 2, minus 2. Want to find the time, right? Very simple. Very simple. I am stopping from here, then minus 2t equals 20. Am I correct? Minus 2t, if you move this side, it becomes plus 2t. It becomes plus 2t. That means 2t equals 20. T means 10 seconds. I done few questions. Remaining questions we'll do tomorrow, next day, next day, next day. Now we are going back to again motion graphs, 1220. Second. Hands up genuinely, genuinely. Huh? If you didn't understand, don't raise your hands. Okay? Hands up genuinely. Up to now. Now what we learned today? Today we started Newton laws and forces. Very important section. It's very, very important section. I am explaining everything with very clear definitions. I can guarantee that. I can't entertain, but I can teach you very clearly. Whatever we learned today until here, until the last question 11, if you understood everything properly, raise your hands. Understood? Hands up. Raise your hands. Okay. So then I'm stopping here means stopping here means not stopping the class. So we'll stop Newton laws for today. Next week we are starting again and continuing. Again, go back to that motion graph section. Motion graph, I think we were discussing. Amaya, tell me what was the last question we discussed motion graph? Take the motion graph tute. Last question. I don't know everything. Okay. You got ready, okay?
Different ways are there, bro. Can please tell me what was the last question I discussed in motion graphs? Can someone tell me? Need a reply? Can someone tell me? Now you want to reply? You guys want to reply to that Nasmia Jaufar account, not Ali. Reply to Nasmia Jaufar account. I think we discussed 15. Bro, you have the phone, right? And where is your motion graph tute? So give that motion graph tute to me, and I'm looking that you can manage with your phone, right? I shared in the group, right? Motion graph tute. I shared in the group again. Put and share it. Uh, anyways, I'm drawing the diagram, right? You can listen it. Okay, listen it. Okay, right. 12:25. 12:25. Today we'll discuss remaining motion graph questions. 15, not 15, right? What 15? Why you guys report 15, 15? I didn't understand 15, 15. I think we discussed question number 6, right? Now both of you mentioned 15, 15. I don't know what is that. Can you guys reply what is that 15, 15? Need a 5-minute break? No need, right? Within half an hour we are stopping the class. What is that Amaya and Rauhi? What is that 15, 15? Oh, it's a break time, ni? Okay, okay, okay. Okay. Okay, I shared now. Now can someone now, Amaya, if not Rauhi, if you have that motion graph due, that PDF, can you share again in the group? And bro, see, go to documents and check WhatsApp documents and check whether there's a PDF. Our Fizri, check. Rauhi and other guys, Rauhi or Amaya or someone. Can you send? Can you share that PDF again? Motion graph PDF again. Zuha or Malki or Sharaf or anyone. Can you share it in the group again? Can you share it? If not, I have to share it. Ayo, nothing gonna change my love for you. How much I love you. These are the nights to be remembered. Ah, yes. Share, ni. Thank you, bro. Ravi shared. Thank you so much, bro. Okay, now you can see the thing, ni. So okay, now as I also have the PDF. This is given to this girl. Okay, okay, right. Start doing then question number 8. Start doing 8. Page number. Hmm? Page number 24, question number 7, right? Page number 24, question number 7. Then 8. I am continuously discussing. Okay. Now they are telling in question number 7, A and B are two objects which move in same direction. Now you can't use linear motion equations. Keep in your mind, please don't use linear motion equations for motion graph questions. You don't get marks even you get the right answers. A and B are the objects which move the same direction. VT graph are given below. Initially when t equals 0, A leads by B by 12.5 meters. Okay, first of all, we'll draw the diagram. I am also drawing the diagram. You guys also start drawing the diagram. Without diagram, we can't do anything. Start drawing the diagram. So we won't discuss past paper questions also. It's a velocity time graph. It's a velocity time graph.